Hello, everyone, and welcome to our webinar. Today we have Ken Stevens from Smile CDR, and I'm Denis Gagné from Trisotech, and we will be introducing the topic of automatable healthcare decision and workflow using FHIR. The first portion will be presented by Ken and is about using FHIR. So Ken, it's up to you to present to us about FHIR.
Okay, sounds good. Thanks very much. I'm Ken Stevens. I manage the software development team at Smile CDR, and we are responsible for, among other things, the Happy FHIR, which is the most widely used open source implementation of the FHIR standard. We're going to quickly give you an intro to FHIR here today. FHIR is managed by HL7, an international standards body. That stands for Fast Healthcare Interoperability Resources. Next. All right, so I just wanted to start by framing what the problem is that FHIR sets out to solve. So you'll have healthcare data in a bunch of different systems and different sites, appointment data, lab results, that sort of thing. And the age-old problem is getting this data moving between these different systems. Next. The first solution to this problem was HL7 version 2 that emerged in '89 and continues to be widely used today as the way data is moved between the systems. You can see just barely at the bottom of the screen there an example of what those messages look like. They're pipe delimited. It's based off of old banking standards. Next. The challenge with V2, biggest challenge is really it's a point-to-point protocol. And although there is some defined standards for the formats, in general, the messages you get out of one lab system will be different from the messages you get from another lab system. So building interoperability on top of V2 had really serious limitations. It's very expensive, and you just end up building a bunch of one-off connections. Next. So really the next major initiative to try and solve this problem was in the US, the Meaningful Use Initiative in 2009. And here they introduced a concept of a central repository called a health information exchange. And the best format for representing the data at the time was called CDA. Next. But CDA, while it solved the point-to-point problem, it's still, it does consolidate all the data now. And if you want to find data for a patient, you have a place that you can go to get it. It still had quite a few limitations. The biggest one being that it's document oriented. So it's not really structured. You can't ask this repository questions, except, pull me all the files for this patient. And then you'll just get back these gigantic documents that are difficult to work with. The biggest disappointment of this initiative, the US spent $25 billion on it. And they were expecting to be able to move data between the different healthcare systems using this standard. But it turned out that if you export a CDA from Epic, it cannot be imported into Cerner and vice versa. It turned out not to be an interoperable standard, and it's quite a cumbersome format to work with. Next. So this is the context in which FHIR arose. Next. But FHIR is like CDR in that it's a central repository for all the data, but it solves a lot of the problems that CDR had. So first of all, it is interoperable. So if you can import and export data from the different systems quite successfully with it. It takes a different approach. Rather than one big document with all the information about a patient, it's lots of little tiny resources that are basically JSON payloads. So you have a lab result or a medication dispense, and then these are linked with pointers to one another. So the data is highly structured, and there's a rich query language for searching this FHIR repository. And it's super easy to implement because it's built on all the modern technologies, REST and JSON primarily. So for example, a FHIR repository, you can ask the question of the repository, who in this region has received a COVID vaccination, or which diabetes patients in these clinics that are at this stage of diabetes have received a foot exam in the last year. These sorts of questions are easily answerable using these structured FHIR queries. It's FHIR data. Next. The other advantage now of having this structured healthcare data in a central repository in a standardized format is you can now build apps on top of it. And we're very active in this space, and we see a ton of activity here. Building mobile apps or clinical apps or research apps that want to interact with the standardized data. What's really moved this forward is the recent legislation in the US that's mandating all the insurers to make data available that they have about their patients in the FHIR format. And so we are very busy helping all of these insurers make this data available, primarily through to mobile apps or web apps. Next. Great. Just now a little dive into what FHIR is specifically. So it's really 5 things. It's the data model that's used to represent the data. It's the RESTful API for importing and exporting the data. So those of you who've worked with REST, you know, there's standard messages for updating, reading, searching data. It's a collection of open source tools and open FHIR servers. So there's test FHIR servers out there on the internet that you can query if you want to, you know, try out exchanging data with them. And one of the big changes with the FHIR initiative is it's a very open community. The standards are all open, and the tooling is open, and even the vendors are highly collaborative and work with one another. So we're moving away from proprietary locked down data formats where you have to hire specialists to work with that data, and towards an open source, open data standard approach. Next. So the FHIR, so when it first came out, had a manifesto, and this was one of the tenets of the manifesto that drives the modeling decisions. So rather than try to model everything comprehensively, the decision was made early on, the models will just cover 80% of the most common scenarios, and then have an easy to use way of extending the data in ways that you need to. The most common way people I see using these extensions has to do with workflow. So the way that you represent, you know, a lab result will be the same from one environment to the next, or an observation, but the way that you are managing patients in a cancer clinic versus a dermatology clinic or whatever it is, the workflow processes are going to be different. So that those workflow process elements tend to get captured in that 20% extensions, but the actual sort of healthcare data that systems that are exchanging the data care the most about, those are all standardized. Next. Yeah, I mentioned this before. It's all of the specs are licensed under Creative Commons. There are many open source tools available for them. Next. Super easy to adopt. So that's been another big innovation of FHIR. The fact that it's based on REST and JSON. Anyone who's built any apps in the last 10 years has worked with these tools, and all of the technology tools out there all support these standards natively. Even security, the security for FHIR is built on OpenID Connect, which again is just supported by anything out of the box. Next. Yeah, so just talk a little bit about what the resources look like, so how the model is. This is some example. There are 150 resources. So there's a patient resource that defines a patient, encounter, observation, diagnostic reports, or medications. Next. If you go to the FHIR page, you'll see this is the list of the resources themselves. You can see they're organized into clinical resources versus sort of patients and organizations and practitioners, those more common resources. You'll see here that there are letters, the N beside resources. There's a maturity model here around this model. So patient, for example, is normative. That's what the N stands for. That means that model is not going to change. 3 is also very stable and is very unlikely to change. One nuance here is FHIR itself has versions. So there's a FHIR version 2 that was somewhat adopted. Version 3 was fairly widely adopted, but now version 4, the version we're on, is by far the most widely adopted version of FHIR. And the US recently, this legislation that's mandating insurance companies make patient data available using FHIR, that is on the FHIR version 4 specification. So I suspect that FHIR version 4 will be the dominant version for years to come. Next. This is what if you Google search FHIR patient, this is what you'll see. just gives you a sense of what the model actually looks like. There's cardinalities and types. And next. This is my last slide here. I just wanted to give you a taste of what a JSON payload looked like for an observation here. So that first section is called metadata, where it keeps track of the versions of the resource that they had changed, and then there's your custom extensions. Then the next section is text if you want to render it, and then lastly is the coded structured data itself, which is indexed by the server and searchable by a rich search language. That's it.
Well, thank you very much, Ken. This was a very good overview and gives us a good sense of what FHIR is and how it can be used and how it represents the new normal in terms of interoperability. New normal being the term of the year, I guess. So now let's look at how we can easily add some decision and workflows on top of FHIR. So the approach we're going to present here is based on the BPM Plus Health Community approach. And basically, the BPM Plus Health Community is an organization that was created to promote the best practice around shareable clinical pathways and other knowledge artifact or healthcare knowledge artifact. There's a field guide that gives you a very good introduction to this approach, and it's available for free, and you can download it on the website. The URL is at the bottom, bpm-plus.org, and you can freely go get that field guide. Now let's agree on a little bit of basic terminology together. So when we talk about workflow automation, what we're talking about is really technology-enabled orchestration of activities, and very important, that is able to react to business events. So we're not just interested in orchestrating things, we're interested in orchestrating activities, but be able to react to events as they happen. And when we're talking about decision automation, we're talking about technology-enabled decision. That means returning answers, giving some inputs. Now, both workflow automation and decision automation may have human in the loop or not. To do this, we're going to be using some tooling that is based on some international open standard. In the case here, more specifically, OMG, the Object Management Group Open Standards. We're going to use DMN, which is the Decision Model Annotation. And DMN is a visual notation to capture things like decision tables and logical expressions. Then we have BPMN, the Business Process Model Annotation. And BPMN is a visual notation to capture prescriptive sequence of activity. And then we have CMMN, the Case Management Model Annotation, which is a visual notation to capture the declarative nature of unstructured work based on event condition action structure. So the recurring term here, as you can see, is visual notation. Now, armed with these tools, we can start looking at answering the healthcare call to action, being empowering the patient, moving to value-based care, ensuring and advancing interoperability, promoting the use of new technology, because we're doing the double catch up. We want to standardize things, but we want to also be able to adopt and include new technologies as it becomes available. And naturally, in the end, it's all about also reducing the clinical and administrative burden of everybody. So what are the benefits that BPM Plus Health brings to us? So BPM Plus Health provides us with a visual story of the patient's progress. And that's very important because from this, we get better coordination of patient care. We also get standardized clinical pathways. And from there, we get a rapid access to evidence-based best practices. It provides data in context. This gives us better decision at the point of care. It also provides us improved organizational and operational efficiency, which gives us better clinical and financial outcomes. Yes, clinical outcomes to the patient is important, but we know it's still a business, so we have to make sure we improve both sides in sync. So when we say provide a visual story of the patient progress, these notation are visual. It gives you the story of what needs to be done next. So here I have a BPMN, a business process model annotation diagram. Whenever you see a circle, it means an event. So a thin circle is a start event, a thick circle is an end event, and double circle means intermediate event. And as I'm flowing through, the rounded rectangles are tasks or activities that needs to be done, and the arrows shows me the sequence of what needs to be done in what order. And then I get to a particular diamond, and that's a branching moment for the routing behavior where I can do either or both of these path and carry on. And then we have that little dog ear flap document here that is the notion of information or data at the right point. So it's a very visual type of capturing the logic of the flow and the logic of the decision that is easy for clinicians and subject matter experts to understand. But the real bonus is these diagrams become executable by machine as well. So that's where we have a single rendering for both purposes. So when we talk about standardized clinical pathways using BPM Plus, the big point here is a single knowledge artifact that is visual, that is both for the clinician and for the automation. So basically, that one model, that BPM Plus model, is the guideline narrative documentation. That same model is the guideline behavior specification. And again, the same model is the guideline logic and is the guideline automation code. So from an artifact or knowledge artifact management point of view, you only have to manage the life cycle of a single knowledge artifact rather than having multiple knowledge artifacts that have to be synced, manage the life cycle, and all this work that we all know too well that is very problematic. So BPM Plus provides us data in context. So here's a COPD initial assessment example. And you can see that at each step here, the table's shape is a decision. So at each step, I can see exactly what inputs I need, what output is provided, and I can follow the logic here. I have an exclusive choice, and I can branch through and making sure that the right data is used at the right time within the flow of this particular guidelines. Now, we also mentioned the possibility of improving organizational and operational efficiency. And we get that really from deciding, not only from the automation, but from deciding whether we have human or knowledge worker in the loop or not. So when we do have knowledge worker or human in the loop, we talk of an attended type of process or human-centric process. And there, the engine or the tooling is there to orchestrate the activities, but we leave it to the human to confirm or provide inputs or to make the actual decision or to carry out the task. So that way, we're basically using humans by providing them with a veto power of what's going on. We can also go to the other extreme where we have unattended or straight-through processing, where the sequence of activities are completely managed and orchestrated by the engine. There you will have things like medical calculators, scoring, categorization. And in those cases, really our goal is to eliminate the mundane task and decision from the workflow of our clinical personnel. So here, again, retaking my COPD example, on the right is the first example I showed you earlier. And on the left here, I added a subject matter expert, a human in the loop, that will validate the clinical data before these decisions are done. So very simply, very visually, we can see here that now I have a human in the loop rather than having a straight-through process to do this initial assessment of COPD. Now, the BPM Plus approach also fosters best modeling practices of separation of concern. That is, that we can go from the narrative to what we call a computational independent model, that is, that it just specifies the behavior we want, to a platform independent model where we specify the logic and how the logic should be, and then to a platform specific model where this same logic is now executing against a particular target. In the context of this discussion, it could be CDA, could be V2, or it could be FHIR version 4. As we progress through there, our BPMN, CMMN, DMN model are augmented with data type and logical expression, which provides us models that are executable. And then we can add the specific binding to the specific data source, in this case, FHIR. So the single artifact can grow as we progress with our best practices of separation of concern. So what we're going to show you now, what we want to show you now is how, using the Trisotech Digital Enterprise Suite platform, we can add decision and workflow on top of a SMILE CDR FHIR server. So basically, visually here, the notion of a wrapper of decision and workflow around FHIR and a FHIR, the SMILE CDR FHIR server in this particular case. So for the more technical people here, here's a little bit more detailed architecture. So we're going to push these models from the modeling to the automation. And this is going to go through a sandbox that emulates an EHR or EMR. And this sandbox will be interacting with a SMILE CDR server for the FHIR using FHIR and CDS hook. So let me switch to a little bit of a demonstration. So here I have an emulator of an EHR, and basically this particular data that you're seeing here is connected to a specific SMILE CDR server that is there for Trisotech demo purpose. Now, all this patient data that is available here, the different pages that I have, all this information, the observation, the conditions, they're all fed from that SMILE CDR FHIR server. So now what I can go, I can move from my model, my diagram, publish it as a service. And now, so let me go and take this straight-through processing version of the server, and I'm going to go here and select that service and come and drop it. Oh, sorry. Come and drop it here as a new service running on top of the FHIR server. Now that could be your legacy EHR, EMR, that could be what you have now, or it could be a FHIR server. And you can see now that I'm getting the CDS hook card back that Daniel Summerfield, he's got a possibility of COPD. He's a gold grade 3 and is in the ABCD group, group A. And that's all coming from that model that we saw there. It ran through all this and made all this decision for us. And as I switch from patient to patient, then you see it runs. There's no possibility of COPD for Melanie. And so you can then switch from patient to patient, and the fact of switching from patient calls that service for you. Now, I can also go and add the clinician in the loop. So if I go and take this endpoint and add it to the service here, now I have the two versions running in parallel, which is probably not what you would be looking for, but here you can see with the human in the loop, when it gets to the point in my diagram where the human needs to be involved, the clinical person, to validate the clinical data, I click there. It takes me to the data that it will use. And if I just use it as is, you can see that for this patient, I have a gold grade of 3 and a ABC of A, which gives me what I had there when I ran it in straight through. Now, naturally, the clinical person, the care provider, could change the data when the data is provided, say, no, this value is erroneous, I just took it again, and here's the value it should be using to do all this. So hopefully that gives you a little bit of a sense of how, very simply, using visual notation standard, we can add decision and workflows on top of FHIR or any EHR or EMR that you may have, providing you with very useful content to use. So let me move here. So this is basically Ken and I's presentation. We hope that we've been able to give you a very quick look at how you can use FHIR and automatable decision and workflow to get better coordination of patient care, better decision at the point of care, better decision and better clinical and financial outcome. We're open for questions. If anybody has some question, you can use the question tab at the bottom and type in your question in there. So answering the proverbial question to all of these presentations, yes, the recording and the slides will be available in the next few days. So we don't really have any questions coming in yet, so people are a little bit shy. So Ken, how can I use the Smile CDR server to expose data that I already have in my environment?
Yeah, great question. That's always the first step when we bring FHIR into an environment, is how can we get the data into that repository. So we have plenty of tools. So we can read in HL7 v2. We have a rich mapping language that maps v2 into FHIR. Or you can normalize it into CSVs. We often start with CSVs for batch loading. And then we also have some real-time loading as well. So the REST API is real-time, and also we support Kafka or ActiveMQ channels for loading the data asynchronously.
Okay, another question for you, Ken. Somebody asked, can you please specify why CDA is not really interoperable?
Oh, yeah. So I did a project in Oregon where we were aiming to do just that, and we were surprised that the data. I mean, I guess the short version of the answer is that the spec is open to interpretation. So the CDA specification allows you to represent the data, just even where to find medications, for example, in a CDA document was not locked down when meaningful use came out, and that's what I believe what resulted in. Now I know the ONC has done quite a bit of effort to improve that, but it's what it can't do is export data from one system and then import it as structured data into another system. That's really the shortcoming of CDA. It largely got used as a document that could be human readable to replace a paper chart.
Okay, thank you, Ken. Another question: is it a fair statement that many development efforts don't take the time to take such a process focus approach? What do you think that it is? Let me take this one. Yes, it is a fair statement that not too many people take that process approach. I guess it's a part of the legacy way of doing things. But now that we have more simpler visual standards to capture these notions, the exercise of capturing this process approach is very valuable. And sometimes we find that a lot of value is gained right up front when people have to agree on what the sequence is and what the decision is and how it should be made. And that exercise of illustrating that knowledge brings forward a lot of discrepancies between how things are done in an organization anywhere. So then we realize, no, we never do it that way. Oh yes, we do it every day like this. And so that conversation brings also a lot of value to regulating the way things are done and to adhering to best practices. Anything you would like to add, Ken? Or? Okay. How do DMN rules and BPMN tasks reference subject variable, e.g. sex, BP, independently of the data source? Yes, so during the presentation there, I discussed the different layers going from the computational independent model to a platform independent model to a platform specific model. Now, the platform specific model is at the end the target you point that rifle to. So you can do it so that you collect that data either from already registered information in a FHIR server in this particular case, or in a database somewhere, or in even an Excel sheet somewhere, if your organization is like 90% of all organizations and run on Excel. So you can connect this to any platform-specific information gathering. Another way of dealing with this kind of information is to do what I've shown, is to put the human in the loop. So some of these entries may be captured by the caregiver, the person there, and enter that data as it's needed within the flow of the care. Hope that answers all your questions. As experience to date shown, BPMN is too deterministic. Does CMMN solve such problem in practice? Expedition, redo, and task. Well, so BPMN is quite expressive, and the limitation usually is the modeler's knowledge of BPMN. So in BPMN, there's some constructs that are called basically some event-driven sub-process that can basically come and act on events at any time and either interrupt the flow or amend the flow of BPMN. So those constructs are within BPMN, makes it quite expressible. People tend to stick to the flow, the happy path we call, of activities, but there's a way of augmenting it. CMMN does bring a different point of view, of a more contextual information point of view, and reacting to events. So it's more of an event-driven approach from the get-go. So both can be used to solve many of those situations. Another question for you, Ken, is Smile CDR fully targeted at the US market? Could it be used to create FHIR repository service for the UK healthcare data?
Oh yeah, we're actually present in, I've lost track, maybe 15 different countries. It's quite international. There's really nothing US centric about it.
Yeah. Other maybe that the FHIR adoption seems to be more predominant in North America, but it's also very present in Europe. I actually, if I recall, Holland and is very active. Belgium, there's a lot of countries in Europe that are quite active around FHIR.
Yeah, Germany, Scandinavia are moving quite quickly with it. Australia and New Zealand are very far with it as well.
So unfortunately, that's all the time we have for today. We got some more questions there that we will take the time to answer by email to you. If you're missing some answers or you want specific answers, both Ken's email and my email are at the bottom of this last slide. We invite you to contact us directly. Thank you very much for attending, and we hope we have managed to provide you a little bit more knowledge of what's possible with clinical share pathway. Thank you all. Have a great day.
Thanks.